Victor Black.
Victor Black.
Uncle Victor.
Victor Black Masterclasses.
Mr. Victor Black.
Virtual Victor, the safer use model.
Why endocrinology matters for PED coaching. Before we talk about specific compounds, we need to understand how hormones actually work in the body. This matters because if you're coaching PED users, lab work is one of your most important tools. Hormones don't just show up on panels by accident. They influence cholesterol, liver enzymes, lipids, kidney markers, mood, water retention, everything. If you don't understand why those changes are happening, you'll end up guessing instead of coaching. This lecture isn't about memorizing pathways. It's about understanding enough physiology to make intelligent decisions when labs come back abnormal. What is a hormone? So let's start simple. A hormone is a signaling molecule produced by tissues or glands that gives instructions to cells. That's it. Hormones are how different parts of the body communicate. They tell cells when to grow, when to slow down, and when to adapt. In this course, we'll divide hormones into three main classes. First, eicosanoids, which come from fatty acids. These play a big role in inflammation and hypertrophy. Second, protein and amino acid-based hormones like insulin, growth hormone, and melatonin. And third, steroid hormones. These are the ones we're focusing on today. Steroid hormones, the big picture. Steroid hormones are all derived from cholesterol. They're produced mainly in the gonads and adrenal glands. That means testes, ovaries, and adrenals. They fall into 5 major groups based on the receptors they bind to: androgens like testosterone and DHT, estrogens like estradiol, progestins such as progesterone, glucocorticoids like cortisol, and mineralocorticoids like aldosterone. Here's the key coaching insight. Anabolic steroids don't only interact with androgen receptors. Many compounds cross-react with estrogen, progesterone, glucocorticoid, or mineralocorticoid receptors. That's why different drugs produce different side effects: water retention, mood changes, lipid shifts, blood pressure issues. If you don't know the receptor profile, you can't predict the outcome. Upstream and downstream hormones. All steroid hormones start from cholesterol. Cholesterol gets converted into pregnenolone, and pregnenolone is the master precursor. From there, it branches into multiple pathways. It can become testosterone, it can become estrogen, it can become progesterone, or adrenal hormones like cortisol and aldosterone. This matters because when you introduce an exogenous hormone, you suppress upstream production. That means taking testosterone doesn't just raise testosterone, it can lower pregnenolone and downstream neurosteroids. That's why some users experience brain fog, sleep issues, or mood instability, even when testosterone levels look good on paper. Understanding upstream suppression turns you from a drug selector into a problem solver. Pregnenolone, cortisol, and stress. Pregnenolone is also the precursor to allopregnanolone, a neurosteroid critical for brain health and cognition. Chronic stress, high cortisol output, or certain drugs can shunt pregnenolone toward cortisol production. That can leave less available for progesterone and neurosteroids. You'll see this in lab work. Low pregnenolone, high cortisol, sleep issues, anxiety, poor recovery. This is why labs aren't just numbers. They tell a story about resource allocation inside the body. Statins, cholesterol, and hormone production. Here's a practical example. Statins lower cholesterol production. Cholesterol is the raw material for steroid hormones. Lower cholesterol can mean lower pregnenolone, which can mean lower testosterone. Now you understand why statins sometimes suppress hormones, not because they attack testosterone directly, but because they remove the building blocks. This is what separates surface-level coaching from real endocrine literacy. Steroid transport in the blood. Steroid hormones are hydrophobic. They don't dissolve in water. Blood is mostly water. So steroids need transport proteins to move through the bloodstream. About 90% of circulating hormones are bound to proteins like albumin and globulins. These proteins don't just carry hormones, they regulate activity and half-life. Bound hormones are inactive. Unbound hormones are biologically active. This balance is what you're actually seeing when you review lab work. SHBG, albumin, and free hormones. Sex hormone binding globulin, SHBG, binds testosterone very tightly. Albumin binds it more loosely. That matters. SHBG extends hormone half-life, but reduces immediate activity. Low SHBG increases clearance, but increases free hormone availability. High androgen use suppresses SHBG production. The body is trying to clear excess hormones faster. This is why steroid users often show low SHBG on labs. It's not random, it's adaptive physiology. Clearance, liver, and gut function. Steroid hormones are cleared mainly by the liver and kidneys. They're excreted through bile and urine. This is why gut function matters, especially for estrogen. Poor bile flow or constipation can cause estrogen to recirculate. So when you see high estrogen, sometimes the solution isn't a drug, it's fiber, digestion, and liver support. Once you know the pathway, you know where to intervene.
Victor Black.
Victor Black.
Uncle Victor.
Victor Black Masterclasses.
Mr. Victor Black.
Virtual Victor, the safer use model.